Section 4. Applying quantum ontology. As Stapp says, the paradigmatic example of an actual occasion is an event whose mental output is an addition to a stream of human conscious events. He goes on to explain that the physical output from this same actual occasion is the actualized neural correlate of that mental output. In other words, the neural activity in the brain which underlies that conscious event. Stapp describes such events as high-grade actual occasions, but adds that Whitehead's quantum ontology includes simpler occasions which have lower-grade outputs. This leads Stapp to claim that the Whitehead quantum ontology is essentially an ontologicalization of the structure of orthodox relativistic quantum field theory, stripped of any anthropocentric trappings, but supplied with an internal creative process that makes ideas dynamically effective. This approach takes the physically described and psychologically described aspects of contemporary orthodox relativistic quantum field theory to be exemplars of the elements of a general non-anthropocentric ontology. What Stapp is saying here is that by looking behind quantum observations, Whitehead has created an ontology in which consciousness and ideas are a creative and inherent part of nature, rather than an unexplained intrusion. There's a general but subtle misunderstanding about quantum processes to the effect that once the wave function collapses, we leave the quantum world and enter the world of classical physics. Stapp seeks to refute this view. He says, counterintuitively, the entry into actuality of the element of discreteness, wholeness, represented by von Neumann's process 1 action, cannot be adequately represented within the conceptual framework of classical physics. He's concerned here with the role of consciousness. Stapp says that his proposal is not that every quantum event need be associated with a reality of exactly the kind that populate our human streams of consciousness. It is rather that every quantum event is associated with an element that cannot be adequately conceptualized in terms of the precepts of classical physics, but that resides in a realm of realities that are not describable in terms of the concepts of classical physics, but that include our conscious thoughts, ideas, and feelings. So while it may not be the case that every quantum event produces an event in consciousness, it is absolutely the case that every quantum event does reside in a realm that contains consciousness and feelings, and that consequently cannot be adequately described by classical physics. Stapp discusses von Neumann's analysis of measurement. This shows that, for all practical purposes, events can actually come into being without requiring any human observation. But, he says, some sort of intervention is then needed, and a natural possibility is that any actual intervention is formally like an actual human observation. This formal similarity to a human intervention involves a number of elements. Firstly, the making of the required choice from a basis in a vector space. This choice, von Neumann says, injects an element of wholeness completely foreign to classical physical principles. Secondly, formal similarity to a human intervention imposes a conceptual element which resolves the ambiguities generated by the uncertainty principle. All this, Stapp says, is in accordance with Whitehead's demand for a mental pole. This conceptual component can have no more complexity than the physical structure that will, after the event, represent it in the quantum physical state. This last statement of Stapp's reflects the complementarity of the mental and the physical in Whitehead's ontology. Stapp is critical of Bohr's pragmatic quantum philosophy because of its emphasis on the active role of human beings in the development of scientific knowledge. This approach, Stapp says, can easily lead to an anthropocentric conception of reality. Stapp brings in Whitehead's ontology as a rational escape from this parochialism. Whitehead can achieve this because he created a conception of natural process that captures the essential innovations wrought by quantum theory in a way that allows the human involvement specified by quantum theory to be understood within a fundamentally non-anthropocentric conception of nature as a whole. Stapp cites two quotations from Heisenberg regarding the nature of the probability function and how observation changes it discontinuously, transitioning from possible to actual. Firstly, Heisenberg says, the probability function combines objective and subjective elements. It contains statements about possibilities, or better, tendencies, potentia in Aristotelian philosophy. And these are completely objective. And it contains statements about our knowledge of the system, which of course are subjective insofar as they may be different or different observers. So, according to Heisenberg, in the probability functions mix of objective and subjective, it is the statements about tendencies which are objective, while the statements about our knowledge of the system, which is subjective, because this may be different for different observers. Secondly, Heisenberg says the transition from the possible to the actual takes place during the act of observation. The observation itself changes the probability function discontinuously. It selects of all possible events the actual one that has taken place. Since through the observation our knowledge of the system has changed discontinuously, its mathematical representation has also undergone the discontinuous change, and we may speak of a quantum jump. Heisenberg is here describing the collapse of the probability wave function. The act of observation changes the function discontinuously, selecting one actual event out of all the possible ones. As a result, both our knowledge of the system and the mathematical representation of this knowledge change discontinuously. This discontinuous change can be called a quantum leap. Stapp claims that the core issue for both Whiteheadian process and quantum process is the emergence of the discrete from the continuous. He then illustrates this problem by referring to the decay of a radioactive isotope located at the center of a spherical array of a finite set of detectors, arranged so that they cover the entire spherical surface. The quantum state of the positron emitted from the radioactive decay will be a continuous spherical wave, which will spread out continuously from the center and eventually reach the spherical array of detectors. But only one of these detectors will fire. The total space of possibilities has been partitioned into a discrete set of subsets, and the prior continuum is suddenly reduced to some particular one of the elements of the selected partition. Stapp then asks, but what fixes or determines this particular partitioning of the continuous whole into the discrete set of subsets? As he points out, the orthodox answer is that the experimenter decides. Yet, if the experimenter himself is made wholly out of physical particles and fields, then his quantum representation by a wave function must also be a continuous function. But how can a smeared out continuum of classically conceivable possibilities be partitioned into a set of discrete components by an agent who is himself a continuous smear of possibilities? How can the definite fixed boundaries between the discrete elements of the partition emerge from a continuous quantum smear?